Hello everyone. Welcome to this session on a new vision for food safety. We have three experienced entrepreneurs with us. At first we have Erik. Erik did his undergrad from University of Pennsylvania and then he served in the US Army for 7 years. He was even deployed in Afghanistan. Later he did his MBA from Harvard Business School and now he is the Chief Executive Officer of SafeTraces, based out of San Francisco. And then we have Devendra. Devendra did his MBA from MDI Gurgaon in India. He has almost 18 years of work experience in technology and analytics. He was the head of customer analytics for KPMG India, and now he is the co-founder and CEO of Intello Labs. And then we have Yonathan. Yonathan is from Uruguay. He did his MBA from Duke University. And he worked as a blockchain consultant in Deloitte, and right now he is the co-founder and CEO of Intello Labs, which is based out of Silicon Valley. So I'll now hand over to these three panelists. We'll start with Erik, and then we'll go to Yonathan, and then we'll go to Devendra, and I'll let them speak. Thank you.
Great. Well, thanks so much, Avinash, and great to speak with the other panelists and everyone who's out there listening. I'm going to give a brief presentation on SafeTraces and where we fit into the traceability ecosystem. So just give me a second here and I'm going to share my screen. Hey, Avinash, when I go to share my screen, it's telling me that there are no more seats left in this event. Yikes. Well, I'll give it. Hey, Avinash.
Can you try now?
Okay, sure. Give me one sec. Huh, it's not working. Anyway, I can just talk through it, so no worries. Okay, well, so if we can get the screen share up, I'll switch back to the presentation, but I'll just talk through this. So it's great to speak with everyone. SafeTraces is a company that's based out in Pleasanton, California, in the East Bay. We've been around for since 2013. And our focus is providing kind of on-food, on-product traceability through a DNA barcoding-based system. So traceability today, or many traceability solutions, rely on either legacy packaging-based ways of tracking things, either through product labels or 2D barcodes or so forth, or increasingly more relevant recently, they're digital ways of tracking things through blockchain and through other ways of capturing the data of traceability. Where we come in is we provide the physical kind of link to product. So for the packaging-based systems, when you remove the product from packaging, you're often losing a lot of the traceability information. So things like establishment numbers, lot numbers, barcodes, all that stuff. If the product is not in that package, then you kind of don't know, or you lose a lot of that information. Whereas through our system, you're able to put a small, invisible, edible, flavorless DNA barcode. And so we take DNA from seaweed, encapsulate it in food grade materials, and then are applying very trace amounts of this DNA barcode at kind of a parts per billion, parts per million type level directly onto the product, whether it's a piece of produce, a kernel of grain, a meat or seafood product, and then we even work in non-food chains like pharmaceuticals and otherwise. And the value that provides is that you have a kind of tamper-proof on-product link that even if the packaging is removed, you're still able to swab test or take a sample of the product, run it through a relatively simple PCR-based test that reads the DNA, and then there's a whole data and software backend that is able to match the barcodes from the point of origin where the product or where the barcode was applied to then the downstream receiver being able to then connect back the DNA signal from the barcode back to that original supplier. So it's pretty innovative, groundbreaking stuff. Just to call out a few specific applications and commercial use cases to give you a better sense of how this works. Right now we're working with Borton Fruit, which is one of the main apple grower shippers based in the Pacific Northwest of the US. They are using our product largely as a quality control and kind of safety assurance mechanism, and the barcode becomes part of the carnauba wax coating that goes on the apple, and so we become part of that mix. And so when you're waxing the apple, the DNA barcode is part of that wax, and then when the apple is shipped off to a retailer or downstream in the supply chain, either on a routine basis or on an incident-driven basis, if there's a recall, then someone can take a swab test and within a half an hour figure out where that product came from, in addition to the kind of stickers that go on the apples. A second exciting application of our technology is in the bulk commodities space, and specifically on products that are either identity preserved or where there's concerns about the sustainable sourcing. So we're working on palm oil coming out of plantations in Southeast Asia, where there's been a history of environmental and labor abuse associated with the upstream production of palm raw material. And what we're doing there is tagging the fruit bunches that then go into the palm oil derivatives. And essentially what's happening is the plantation operators are applying the barcode on the fruit bunch, and then before the fruit bunch goes into the mill and is milled, there's a sample taken to confirm which plantation it was coming from, and then you're getting assurance of the ethical, sustainable sourcing of the product before it goes into the commercial chain. That our data is also then networked with other satellite data and other traditional supply chain data like bills of ladings and other information to then create kind of a stack of data where you can reference against each other and confirm the source of the product. A final application that I'll mention is just on meat products. So this is more of a last mile traceability where product coming from a primary processor into a restaurant, retail location, or a food service entity is able to have a DNA barcode that is integrated with the brine mix that goes into many meat products. And then in contrast to what happens today when there's contaminated product that hits the consumer and then there's an investigation that happens to figure out where the contaminated product came from. And with meat, it's often removed from the packaging so that you're then sampling kind of the meat and then you get a positive on a pathogen test. You often then need to build a forensic trail of where did this come from and on what day and what processing line. And all of that takes time and is often inconclusive, whereas we can provide a DNA barcode that can be tested simultaneously with the pathogen testing and get you right back to where the product came from. And then you're limiting the quote blast radius of the recall so you can get right back to the problem source much more quickly and efficiently. So really exciting stuff. I'll kind of turn it over to the others here, but really look forward to the questions and the discussion.
Thank you, Erik. I think it's my turn. Very cool product actually, and I think we have some opportunities for collaboration. So I'll talk to you after the panel. I'm Yonathan Lapchik. I'm the CEO of SUKU. We are a blockchain technology company out of Silicon Valley. We've been in the space for almost 3 years, and before this, I was the product lead for the blockchain lab at Deloitte in New York City. So Deloitte was one of the first professional services companies actually getting into blockchain back in 2012, where the blockchain world didn't even exist. It was Bitcoin 2.0. So we've been helping Fortune 500 customers since then for almost 5 years. And then at the end of 2017, We met one of our clients. They were doing supply chain solutions using blockchain, and I decided to leave Deloitte and join them. So that's the client that I'm in. It's the company that I'm the CEO, and actually 7 of us left the lab to join them. So we've been working on this for quite a long time. Our focus is around traceability of products to create 2 main things. The first one is being able to help retailers and brands sell more and sell better transparent products. And the other one is through traceability, as we onboard different partners, give them access to financial tools that they don't have access to today. So we started building this B2B platform 2 years ago with the goal of making supply chain transactions and interactions between the distributors, the retailers, the manufacturers more efficient. So we created a marketplace where they can transact with no intermediaries. And we also created the traceability that goes into that marketplace. And then at the end, we saw that many players in the industry were focusing on the cost saving opportunities, being able to identify issues in real time to save money. But we saw that the opportunities around revenues are probably 10x of what they were around cost due to that transparency. So what blockchain gave us, and Bitcoin, Satoshi, who nobody knows who he or who she is, gave us this opportunity to move from systems based on trust to systems based on transparency and verification. When we look at the market, when we look at our target, is the conscious consumer, is the consumer that we see on a trend that is increasing incredibly, and right now, because of the coronavirus, even more, everyone is going to be a conscious consumer. But that conscious consumer is the one that actually is looking for transparent, sustainable products, and they want to buy those type of products, and they don't do it because they don't trust the brands. There's a huge lack of verification of the claims that the brands will make around those products. And that's our goal, being able to be in the middle, helping brands connect with this new consumer, being able to speak the same language, and for the consumers to look for these transparent products. So it's all about what they care about. They don't like products just because of the flavor anymore. They're looking for the story. They're looking for the transparency. They're looking to be able to be part of giving back to the community. So those are the intangibles that we have been working on. One of the first use cases that we worked last year was with the second largest retailer in Latin America, a company called Cencosud, a very large retailer. So we started in Peru to track meat. We involved 10 different participants through meat traceability all the way to the farmer. And with our application right now, you can go to the supermarket in Peru and you go to the aisle. Every package has our logo and the QR code, and then you can scan it and get the entire traceability. You're able to see first a video of the farmers, like getting that connection with the end of the chain, and then being able to see all the steps on what happens specifically with that product, not generic, not in a generic way. You're actually looking at the data for that single unit. So you can actually scan one and then scan the other, and you will see how many days they've been sitting on the aisle. So with that information, we wanted to also bring the end of the supply chain closer to the consumer, being able to interact with them, getting to know them. And it's a story about transparency. It's a story about traceability. It's a story about being able to help with food safety, but it's also about revenues. It's also a story about creating real value for this company on the revenue side. And after a few months, we were able to prove that our technology actually helped them increase sales, because now they're addressing a market that they were potentially not being able to address in the way that they wanted. And I think that's a huge validation for us. Right now, we are trying to expand into other countries of Latin America, replicating the model here in the US, and obviously Asia, which is a region that really needs this transparency, really needs this verification and authenticity tools to go through that. So yeah, cool story. And we've been partnering with a company called SmartTrack. When you think about traceability, And it's exactly what Erik was saying. You always need to have a way to link the physical world with the digital world. And through all the cases that we've been going through, and it's food, but it's also about other verticals, then you always need a partner that I can actually give you that second verification. If something came from Chile, then I want to be able to verify if it actually did come from Chile. And this company, they were one of the biggest NFC manufacturers in the world, a company from Netherlands. They were just acquired by Erik Denison, the biggest labeling company in the world. So we've been partnering with them on all these use cases where we need to link physical assets to the digital ones. Again, thank you for the invite.
Great. Thank you.
Thanks, Yonathan. I think it's my turn now. Hi, everyone. I'm Devendra, co-founder for Intello Labs, and we're based out of India. Primarily, like Yonathan talked about transparency and traceability, we are talking about the third pillar, which is basically your quality and monitoring. Traditionally, quality and monitoring of any fresh produce is being done manually or through labs. Labs are costly, they are time consuming, and they're not available everywhere. So across the supply chain, people rely on manual decisions and subjective judgments to say this is good, this is bad, and accordingly your fresh produce flows across the whole supply chain. And that's happening whether you are a retailer, whether you are a food processor, or whether you are a trader or food service company who's working on it. What that does is not only the judgment is subjective, but it also does that it's at a very macro level. People say it's good or it's bad, and if it's good, everybody assumes it to be good, and then it goes through as it is, and if it's bad, it just gets rejected. Whereas it could be that there are just few pieces which are good or bad, and the manual and in your manual assessment you miss those, or you say okay, these are just few pieces, and you let it go. Another big piece is this manual assessment does not takes into account a lot of ripeness and maturity and intrinsic factors. So this is where Intello Labs comes in. We are digitizing the whole monitoring and the quality solution by using artificial intelligence and computer vision. When I say artificial intelligence and computer vision, it's very simple. You click a photograph and all the checks which were required are being done by our software. We're also doing NIR sensors, which help us add the intrinsic parameters along with the extrinsic parameters or the visual parameters. So combining these two in a very scalable and a mobile fashion, at any point in your supply chain, you can start looking at the quality. You can start monitoring your fresh produce and ensure that the deterioration which happens with time, with the humidity and other conditions, they are avoided. How it works is simple. You could take a photograph through a fixed camera, through a hand phone, through a mounted camera, or on a camera on a bot, and these images go to a server where our software reads those images. First, it identifies individual SKU. For example, if in an image there are 500 tomatoes, then it would identify each of the 500 tomatoes. Then it would classify them, saying, okay, this tomato looks good, this tomato has got a scar, this tomato has got some viral spots, this tomato has got a hole. And then the third step, you would find out the severity of those, which is essentially to see that, okay, is the scar very small, is the scar large, or are the viral spots across the whole surface, or there's just one or two spots, and so on and so forth. And basis the severity estimation, the classification of the piece takes place. And then we aggregate the results for all the 500 tomatoes to give you what's happening in the lot. Now, what this helps you is to understand that, okay, what are the key critical defects or key critical features which I can see? Can I see over ripening in this lot? Because of which I understand that if this has to travel 3 days, by the time it reaches its destination, some of them are definitely going to decay. And if they're going to decay, it's going to impact the whole lot, right? So and this kind of analysis at a very micro level is only possible in a very short time frame, is only possible using digital technologies, and that's what we are doing. And this technology not only we're using for quality assessment through handfuls, but we are now taking it across into multiple use cases. For example, we are working with the picking robots to help pick the fresh produce for e-commerce players, so that all the fresh produce can be picked and packed in a sterile environment with no or minimum human interaction. We're also doing working with our clients in monitoring across which are basically retailers, to monitor the shelves on the retail stores. Now, this helps them continuously monitor the retail shelves and ensure that there is no decay happening, any bad piece which is there on the shelf can be immediately removed, and so that the quality it remains fresh, the consumer gets the good quality, and the chances of the whole shelf or the lot getting bad is minimized. In the same way, we are working at the packing stations. Essentially, what happens in most of the packs which get bad is there is one piece which is bad. It is either rotting or decayed, and that goes through into the whole pack. And since it's in a pack in a condition where there's high humidity or high temperature, the decay moves on to the whole pack. And to avoid that and to ensure that each and every piece in the pack is good, we've created a solution where the mounted camera, while the packing is being done, each and every piece is scanned, and then you get alerts if there's any piece which is bad, and then it can be moved on. So there are multiple ways the whole technology is being used across. We're working with retailers in India, Southeast Asia, US, in China. We're working with food processing organizations. We're working with food trading organizations. We're working with food brands who procure from farmers and then pack them, brand them, process them, and then sell across to retailers. So across the supply chain, we're working and essentially helping them ensure that whatever intrinsic or extrinsic defects could be there, they are able to catch those, isolate those, and make sure they're able to take some action and prevent any hazard or quality issues going through to the customer. An interesting piece I would want to talk about is with our client in India, which is Reliance Retail, which is one of the biggest retailers in India, has got about 1,100 stores. There we are helping them get the quality and the measurement right from the time when they're buying it from the farmers, which is what they call as collection centers. From collection centers to their warehouses to their stores, the quality is being monitored. The same, we're using barcodes and QR codes to make sure that the same lot and the same set of fruits and vegetables are being monitored. So, and then we are measuring that, and then we are capturing the duration across the supply chain. And this has given them a very good example to understand that, okay, how does the fruit quality changes across the supply chain? How can they proactively ensure that the good quality reaches the client, reaches the end customer? I mean, for example, you had papayas. Now, everybody wants nice ripe papayas when they are buying it from the store so that they can consume in the next 2 to 3 days. When a retailer is putting it onto the shelf for 2-3 days, within 2 days, the whole papaya is going to get bruised and brown spots in it, and it's going to start decay, given the conditions. And especially if you add the heat in the Indian environment, the time is even lower what they get. So most of the retailers, they buy green papayas. And as a result, when somebody is buying those papayas, in the early stage, they get a lot of green and unripe papayas. Now, it's a trade-off between the quality and also we were able to trace the whole lot across the supply chain, measure the quality across at each point at different points in time at the same place, and then help them create the right level at which they have to buy. So now what happens is the retailers buying at the right maturity level. They are ensuring that their suppliers, the farmers, are aware of what they are looking at, how to minimize those losses, how to minimize the safety incidents, how to minimize the risks for the consumer, and digitally they are able to check the whole thing and educate everybody across and reduce the losses as well as ensure that the good quality goes in. So that's what we do in a nutshell, and happy to take any questions if anybody has.
Thank you, Erik, Yonathan, and Devendra. We had 2 questions here, but Erik has already typed the answers, and I have a few questions from my side also. So probably we'll just let Erik answer the first question, which is typed here quickly, so that the entire audience can know it. Erik, what is the life expectancy of the barcode, and what traceability after human consumption? That is the example of Apple that you gave.
Yeah, so the life expectancy of the barcode, we develop barcodes to extend beyond the shelf life of the product, actually well beyond the shelf life. So for perishable products like fresh produce, those shelf lives are generally anywhere from a couple of weeks to a few months. But apples, due to refrigeration and other ways that they have, or other methods of extending the shelf life, last pretty long. So there our barcodes can last over a year. And then on commodity crops like grains and oil seeds, it can be over 2 years. So we have some scientific tools that we can use to kind of prolong things. But also just another point related to this is that supply chain conditions definitely have an impact on the life expectancy of the barcode. So if for a commodity product, when you're taking the raw material and then processing it and applying heat and chemicals and other things, then that will definitely lead to degradation of the barcodes, at which point, if that's significant enough, you would then trigger another application of a new barcode. So for commodity crops, it's not like you can put a barcode on a kernel of grain and then it shows up in the cereal box. You would have to have several different points, but often we find that there's one point in the supply chain where there's a problem, the gap in the traceability, and for many things it's upstream from the farm into the first receiving station. So anyway, that gives you some sense, but the bottom line, the barcode can last anywhere from a couple weeks to a couple years. What was the second question was? How does one scan the product? So great question. So the actual DNA barcode itself is read by a PCR machine. So that's a common device for reading DNA, and that would be how you actually take, the swab test or a sample of the product. You put it in a test strip and you run it through the machine. But that information itself, and this gets to, I think, the bigger point, can be networked into a variety of other data sources. So whether it's a blockchain, a software, an ERP, generally we can API the test result information into other sources. So then you're then verifying it against other data sources, whether it's other traceability related data, food safety related data, quality data, whatever. And we've so I think that our data is much more valuable as part of a broader data ecosystem than it is on its own, even though it's valuable on its own. And then the other piece of that question is that while the data today is largely used by supply chain participants in a B2B type of way, so the supplier, producer of a product then, is having the data read by the downstream purchaser, eventually there's an ability to take the data and make it more consumer accessible through QR code type integrations. So those are all things that we're exploring. So anyway, those are the two questions that I got.
Great, thank you. And there is one more really good question. So in the last panel, panelists discussed the issue of who would be paying for traceability solutions. What are your thoughts on this issue, and who do you think are the end consumer for all three of your companies? So this is a question for all three of you. Like, who is going to pay for the solution?
I can start. I think it's a great question. When we think about what we are trying to provide to our customers and retailers is a way to sell more through more transparent products. When we communicate that message and that message gets communicated to the different participants and you can actually show the results, you can then say, if you implement this, then you're going to be able to sell 20% more in the next couple months, right? You are asking them to change a process or to add one more input into the process. So always there's going to be some resistance. Our path was to show them value very quickly. So we were able to show the supply chain participants that actually using this, they could sell more. And that's the incentive that they have. And with that, after we show them that we can actually produce the value to sell more, our goal is to charge the different participants in the supply chain a subscription fee in order to have that traceability enforced by the retailer, which in this case, we call it the king. So we have the right incentive model showing them the result and then charging a subscription fee out of that. When you think about at the end of the chain, so the farmers, suppose you have a coffee farmer in Colombia and you have hundreds of thousands of those. So it's difficult for someone to be in the middle of Colombia trying to report something, right? So what we did is we created a bot through SMS where they receive a message saying, did you sell this bag of coffee to this buyer. And every time that they respond, we give them something. And that something for us is our cryptocurrency. So we use our cryptocurrency in order to give them an incentive to provide us that data that will provide the transparency, that will create the value for the retail, that will make everyone to sell more. And then when they accumulate that crypto, which is a reward, they can do two things. One is being able to spend that into our retailers, the partners, or two, use that cryptocurrency to use it as a collateral to get a loan from our decentralized finance ecosystem. So we also get that incentive for farmers. They will not pay for it; they receive something in return. But I think that's the weakest link for us. So we have everyone incentivized and everyone with a good subscription model to provide that information that we need.
Devendra?
Right. Yeah. So in fact, it's not just about who's going to pay, but it's also about what's the value can they derive, and it changes across each player in the whole supply chain. Now, for example, like Yonathan said, retailers are able to increase their sales because they are providing good quality fruits, fresh produce. They're providing something which is ethically sourced. They're and the consumer savvy for it, and they're asking for it. So they are able to meet their customer demand. Sales obviously is one of the key things which goes up for them. But other important piece of thing is as you adopt these digital technologies, be it across on visual quality, be it across on traceability, your losses and your control over your losses keep on coming down, and your control over your supply chain increases. But now because you're able to pinpoint exactly what's happening on your supply chain and able to react faster to it, so you're able to reduce your losses across, and then the technology starts paying for itself. Similarly, if you look at it, food processing companies, when they're buying in from farmers, today they spend close to anywhere half an hour to 45 minutes on each sample because they want to make sure they're buying the perfect sample. Using our technology, this comes down to 3 to 4 minutes because there's no sample preparation. A count of 500 takes the same time as count of 2 or 3 pieces, right? And the person does not have to do it. He does not have to enter any data. There's no data loss which happens. Everything is connected. So using the same thing, that instead of a person taking 30 minutes to do a sample, he is now doing it in 5 minutes. And which ensures that his turnaround time, his efficiency is increasing. So at the end of the day, yes, the initial cost is probably slightly higher, and we look at, okay, who's going to pay for that initial cost? But in the long run, these digital technologies especially help you in a lot of other ways. It helps to add to your bottom line by reducing losses, increasing the efficiency, as well as adds to your top line by ensuring that you are providing the right goods and providing customer with the great commodities and great produce. So that helps you increase your sales. I mean, for one of our e-commerce clients, they were struggling with refunds. They had close to 4.5-5% returns. They had to refund for about 5% of their orders. And now, since they're able to monitor each and every piece which is going out to the customer, that refund rate has come down by about 30-40%. And that's directly adding to their bottom line. And there's no reason for anybody to look at who's going to pay for the solution. So these solutions, they over a long period of time, they tend to start paying for themselves.
Yeah, Erik.
Yeah. So to me, this is the most important question, because this is where the rubber meets the road of who pays for it. And I think that there's no shortage of really groundbreaking technologies available right now. But the food industry, and I can say this having worked in the food industry and been a trader at Cargill, is extremely cheap, and it's also incredibly it's much slower on a relative basis in terms of how it adopts new technology compared to other industries. And so even if there's clear ROI, it often takes regulation or something to nudge the food industry to adopt something. I think our experience has been that the best opportunities, because we can work from a technical standpoint in a variety of different supply chains, but the sweet spot is where the product is either high value and or high risk. So for premium products that have bigger margins to play with, then there's more of an ability to pay or willingness to pay. And then risk, food safety risk or counterfeiting risk primarily, those are also good candidates. And ideally you have both high value and high risk. for us, we have a hardware component and then a DNA consumable / data component. And I think that in terms of the way things get paid for in our product, the hardware is borne by the hardware cost is borne by the actual processors or the midstream type of people up, and in some cases the producer. But if you're talking about a farmer, they're generally not going to pay for things. They're going to have someone bear the cost. But then the consumable, the DNA barcode plus the kind of traceability as a service and the data needs to be probably transfer priced, as a premium onto the actual food good. And there you're often looking at, pennies per bushel or something, and which is one of our big advantages. We generally come out at about around a couple bucks per ton of product tagged, which is very competitive, and a lot of other solutions are much more expensive to the point where that it's prohibitively expensive. So, but I think, our experience has been just a general reluctance to pay for traceability, and generally it's a pull from the consumer-facing organizations to then force their suppliers to then implement things, either as a kind of safety risk reduction type measure, or they're trying to validate a kind of farm to fork or sustainability type story. So, we have more success, getting a retailer to kind of buy into what we're doing and say, hey, my suppliers need to do this. So.
Yeah, great. Thank you. And I have one more question. So Devendra and spoke about value. The other two of you also touched on value to the customer through your product. So have you created any framework or any methodology to quantify the value that your product can bring to the end customer? This is for all three of you.
Right. Yeah. Right. So basically, see, in our case, what we do is is something what we call as a path to perfect 100% score. Essentially, we help all the retailers or any food processing organization or traders to ensure that whatever they are purchasing and whatever they are selling has a 100% quality rate. Okay. Now, so how it happens is that once we start monitoring the quality and once we start monitoring the produce, we start identifying what are the key problems which are coming in and then trace them to their origin. For example, if there's a batch which has got a lot of viral spots, which means there is some particular farm or some particular area which has got a disease which is going on, and then then there's the vendor who's provided that. Essentially, there's a breakdown in the system somewhere where the vendor was not able to catch that viral incidences in those farms, and then he's purchased it and then he sold it further, right? So in that case, then then it happens that we work with those guys. Our customer works with the vendors to help them show that this is how you need to control it. These are the symptoms you need to catch, and then our technology aids those. So that's just a very small way of how we help trace out each defect, each feature, each issue which could be there in the solution, trace it to the origins, and then create action plans across those. And then help create a path which says that, today digitally you are providing 80% good and 20% is something which is a questionable or maybe a product which needs to be removed from retail supply chain and moved to some other supply chain. And then work with the organizations to take it from 80% to 90, 90 to 95, 95 to 100, and so on and so forth. So that's how we work with our clients and ensure that they move towards a perfect quality.
For us, we divide KPIs in three parts. The first one is around cost savings. So we measure how much time did it take us to identify an issue or a participant that introduced something faulty into the supply chain. Second is around revenue, so directly associated with sales. Were we able to help you with sales, and what was that increase? And third, which is connected to sales, is consumer engagement. We are, with the entire B2B platform that we build, we have an experience through the consumer, and we build those new experiences. We have partnered with a company doing AR, so now how you interact with the brands and with the products. So we have pretty cool stuff, and we measure that consumer engagement as a way to funnel them through sales. So those are the three ways we measure success.
Yeah, we kind of track fairly closely to what was just mentioned. So I think that the clearest value is on the risk mitigation, and for companies that have had either food recalls or have a counterfeiting fraud problem that's costing them real dollars, then we can show concrete numbers around what would be saved or what is saved by using our product to either authenticate or to limit the kind of scope of recalls, so that you're going back, as I mentioned, to where the problem came from, and not having recalls that pull in a lot of your product over long periods of time. The second piece is helping, and this is a little bit more amorphous, but strengthening the company's brand equity and brand story of adopting technologies that show that their food is the safest, most authentic, and most sustainable. And then I think that the third, which is not proven at all, is just the ability to price things at a premium by saying that they're using our technology. I don't believe that market is there today for the most part. But aspirationally, we hope that it is. But I think really our concrete value is on risk reduction, risk mitigation.
Great. Thank you so much. I think we have time for one last question. We have 3 more minutes left. So this is regarding the technology, of course, blockchain, RF, and other are the upcoming technologies. From a technology point of view, which technology do you think is going to be most popular for traceability going ahead?
I'm a little bit biased, but I think blockchain provides the right level of transparency. I think we should remove trust when we describe traceability. Trust shouldn't exist. There's no need for trust. There should be a need for verification, and we think blockchain provides that solution. So the combination between IoT and blockchain and potentially AI, I think those are the 3 biggest ones, and Erik's technology as well, of course.
I guess I'll go. I'm going to kind of cop out of this question. I really think that the winning solution is going to be the platform play. Right now, there are a lot of very valuable different solutions available, but it's overwhelming to the food supply chain and the food industry to kind of figure out, well, which one do I do? And whoever is able to kind of put everything together in a way that becomes easy and limits the choice needed for companies to say, well, I want sensors plus blockchain plus barcodes, and is able to integrate those, I think is going to win the day. And no one has really done that to date. So yeah, that's my answer.
Yeah, I think I agree here. It's difficult to say which one technology is going to take over the precedence, because there are so many different variables which come into the whole equation. There's connectivity, there's geography, there's variety, there's seasonality, so many. But what we'll have to look at it is that the solution, whichever would go through, has to be scalable. It has to be something which a farmer in his field in a country like India or maybe in Philippines or Indonesia, from that level to the biggest of the buyers and the traders in the world, like Cargill and Ola can use. And right, so that it has to be simple, it has to be scalable, and it has to be something which is very mobile. So I believe that it is to be a mixture of maybe blockchain, AI, imaging, maybe some sort of small sensors which are incorporated into the handphone itself, some sort of barcodes or few other codes. So it is going to be a mixture of all the technologies, and primarily should be driven through handphones so that it's easily accessible for everybody.
Great. Thank you so much. This is such an important topic. Now with the coronavirus crisis, I think the importance of food safety is becoming even much more important in the world. It was great listening to all 3 of you and hearing insights from you. Thank you so much for joining us. Thank you, everyone.
Thank you.
Thank you.
Thanks so much. Bye-bye.
Bye.